Hello everyone and welcome to today's webinar on Blueback Project Tracker version 4. My name is Mark O'Brien from Blueback. Thanks for your participation today. To start with, just a quick note on today's session. We're using a GoToMeeting hosted presentation. You should see a panel like this. You can minimize the panel by clicking on the little red arrow. Click it again to bring the panel back. You can display the panel as a full screen or window by the view menu. And by default, everyone is muted, so please submit any questions you have into the text dialogue, and we'll do our best to answer you as we go along. Hopefully, we'll have some time to share some of the Q&A that come in at the end of the session. Lastly, this webinar is being recorded. You'll all be provided a link within 24 hours. Please feel free to distribute as you require. And finally, the recording will also be posted on our website. So moving on to the agenda, so today we're hopefully going to do two things. One, cover an overview of the project tracker and the tools it brings to Petrel data management, and also include a review of the new features that have gone into version 4. Just to let you know, this is it's quite a comprehensive review, quick and comprehensive, but it's going to end up more around the sort of 40-45 minute mark as opposed to the half-hour mark that we've advertised. So as such, we'll work through a few slides to introduce the Blueback Data Management Suite and the Project Tracker. We'll then spend the majority of the time in the live demo covering an overview of the tracker, the new admin GUI, the web front end, the ways in which we can integrate the database with Arcgis and Excel, and also the tracker tools contained within the project management toolbox. Following the demo, we'll then jump back into PowerPoint for a summary, let you know about the licensing evaluations, and the last thing before we share the Q&A is to let you know about the consultancy services we now provide around the Project Tracker. So moving swiftly onto the Blueback Data Management Suite. Our Petrel Data Management Suite currently consists of 3 products designed to help and assist both the Petrel user and the Petrel Data Manager. The Blueback Toolboxes are a set of functionality features not available in standard Petrel, and the Project Management Toolbox provides many features to help keep the projects clean and organized, support for additional import-export formats, tools for reporting and quickly scanning projects. The newest addition to the Blueback Project Management Suite is the Project Time Machine. The Time Machine allows snapshot and backup technology to be realized from within the Petrel interface. It allows for efficient user versioning of projects and user-controlled backup and recovery, and utilizes existing NetApp infrastructure to efficiently store snapshots and incremental changes to projects. The final product comprising the suite is the Project Tracker. So the Project Tracker is a Petrel plugin for data managers to track and monitor Petrel projects from all their Petrel users. It provides a powerful toolkit for managing an increasing number of projects scattered around your network and will be the focus of this webinar. I just wanted to introduce you to the whole of the Blueback Data Management Suite to show you how the Project Tracker fits into this. So the Tracker is a plugin that allows the data manager to track and monitor all projects from all users on the network. Regular scans of the network allow you to collect metrics, to monitor the network and build a picture with time. The Tracker can perform analysis on 2 and 3D seismic data to highlight duplications. It also allows you to identify data object duplication without using Petrel UID. The Spatial Extension module will record spatial data in the database about your Petrel project and data objects and allow you to visualize the tracker database in Arcgis and in turn identify potential data inconsistencies. The Geodata Exchange module allows you to track data in the Petrel environment that is being imported via OpenSpirit. So you can see the tracker comprises quite a rich toolkit which will allow you to implement your desired data management policies and procedures. So the Project Tracker is designed to be the main tool for the data manager. The new rules and alerts in this release allow you to monitor the adherence to your defined data management policies. The crawler will give you an overview of all the Petrel projects and versions across the entire network, which in turn allow you to control duplication of projects, seismic, and many other data types. Regular scans allow you to monitor seismic data usage, see how reference projects are used or not, understand project data history, and follow how both projects and data evolve. The Project Tracker allows the data manager to control and monitor all of the Petrel projects on the network. It allows you to ensure that reference projects and the correct versions of data are being used. It allows you to monitor and project trends, see how Petrel is utilizing disk space, see the number of different data objects per data type, and measure how your data management policies and procedures are being observed. The Project Tracker Utilities module now allows the data manager to perform a bulk upgrade of Petrel projects to the current version if required. And Project Tracker has a customizable and open data model which allows for easy integration with other applications for analysis and for you to customize the measurements, business rules, and views for Arcgis, etc. So as I mentioned, with the spatial extension module license in place, the crawler will record spatial information on the data types we can see here. This allows you to spatialize the tracker database and your Petrel network in Arcgis. Using this utility, you can build a broad geographical overview of your Petrel network, see duplicate and non-reference data in their respective locations. We can also highlight potential data mispositioning by identifying duplicate Petrel objects in different geographical locations. We'll cover more on this in the demo. So the last slide before we move into the demo, and how does all this work? There are three main components: the crawler plugin, the SQL database, and the web front end. So the process is to configure the crawler as to where you would like it to look for Petrel projects and reference projects. For each project that is found, a plugin is attached which interrogates and feeds information on the contents, the measurements, and metrics from the project to the SQL database, where all the data from all the projects is aggregated. Sat on top of the database is a web front end to provide an organized view of the data and network. The database can also be integrated with Arcgis, Arc Server, Excel, and so on. So let's take a look at the software, starting with the administration interface. So here we have the newly restructured and extended crawler administration GUI, or Tracker Admin as it's known, available from the Tracker plugin install directory. So this GUI is designed for you to configure and control where you want the crawlers to go, what you want it to do and record. It also provides control over the analysis, the project actions, the measurements, notifications, and so on. So as you can see, we've separated out the configuration and execution into two separate window dialogues. We also have new windows for the log manager, the tags manager, seismic file manager, a new project rule manager, project manager, and a project upgrade. So we'll work through these in turn, but starting with the configuration. So in configuration and under scan data and then the data tab, firstly we select which data we would like to record information on. We also have a panel here for selecting which data types you wish to record spatial information on. So for every project that's found with a valid CRS, the Petrel coordinate engine will be used to convert spatial information, on these data objects, convert it to this EPSG code, in this case WGS84, so all the spatial information will be stored under WGS84, in this case in the database. Also under scan data we have a hashcode tab. So it's now possible to generate a checksum for these data types based on the actual data content of the data object. This allows you to identify duplicate data without using Petrel GUID. The checksum is presented as 32-character hashcode, which I'll show you in the demo. So moving on to scan folders. So this is where you configure what folders or network drives you would like the crawler to go to and look for Petrel projects and reference projects. So the dialog provides an opportunity to assign a tag to each project found within a particular folder. So for example, I have here the string exploration. I can add it as a piece of metadata or user string, or store this string against all projects found in this particular search directory. So these tags, or these small pieces of metadata, are assigned to each project found in that particular location, and they can then be used to filter, search, and organize the data during your subsequent analysis. So it's also possible to exclude specific folders, exclude specific projects, and you can also use an expression, a global regular expression, to make a more focused search within the folders that you've included under include folders. So moving on to the measurements tab. So here are the measurements that are going to be taken with each crawl or scan. So here we can see we're going to count the projects. look at the data sizes of the Petrel components. So the idea is that you run regular scans, perhaps weekly, using the scheduled task on a Saturday morning when the network's quiet, and generate regular measurements and metrics which allow you to build a picture of your Petrel network with time. So as I mentioned, the database is customizable, so you can actually script your own measurements in the SQL database, and then they can be added in as custom measurements to be executed with each crawl. Under the project and analysis tab, we have project and data analysis, which allows you to analyze the relationships between all reference data, projects and data objects, to understand the parent-child relationships and see how data has been copied and passed from object to object. Seismic duplicate analysis allows you to perform analysis to identify duplicate seismic objects. This means that we can identify seismic data which is an exact duplicate of another seismic object. This in turn will allow you to clean up, rationalize, and ultimately reclaim disk space. So the seismic analysis can be executed on 2D, 3D, or for seismic objects stored within, external to projects, or both internal and external. So the database connection tab allows you to input the server and the database, tracker database to which you want to write the data to. The Petrel tab is where you set the Petrel executable, which license package to use. The crawler uses a single Petrel core license for opening projects when executed. You can also set the timeout here. So this is how long the crawler will attempt to try and open a project before moving on. This prevents it from getting stuck trying to open a corrupt project, for example. The notifications tab I'll come back to in a second. The final tab in the config is the log file tab. This provides options for configuring the log files, where you want to store them, what you want to call them. And these logs are a detailed record of what happened on each crawl, which projects the crawler has failed on, summary statistics, progress of the analysis. And there's a lot of valuable information contained within these crawl logs. So we've set up the crawler, told it where to go, what to do. The next tab down is the execution. So we need to select our execution options. So we're going to select yes, I want to scan my projects. Yes, I want to run some data and seismic analysis as per configuration. Yes, I would like to take a set of metrics with the crawl. It's also possible to take actions against the database. So you can purge the database or remove certain data that the tracker has generated. We can also now for Tracker 4 choose these rules to execute rules and notifications. So these are a new feature for Tracker 4. So it's now possible to define a set of rules for automated checking of Petrel projects against, and if certain criteria are not met, you can automatically send email notifications to data managers and users. So I'm just going to jump down to the project rule manager. So this is used to configure which automated checks or data management criteria that need to be satisfied by each project. So we can see, for example, project must have a coordinate system, project must be one of given versions, and based on the level of warning, severity, so is it an error, a warning, or a tip, you can then automatically generate emails based on these rules not being met and the level of severity. So I'm just going to jump back to the configuration and notifications. So this is where you plug in your email server. You can set up a distribution list for your data managers and your Petrel users, and then you get, it basically generates an email that looks like this. So Petrel was broken or fired. So for this particular project, Asset 1 User 1, warning, project doesn't have field UTM. Warning, it's got seismic stored in the project folder, etc. So you can automatically check projects against standards and then subsequently provide automatic notification. So just to finish off with a run through of the remaining functionality in the Tracker admin, the log manager. So this allows you to view and manage all of the logs you've generated. So with each crawl, a detailed record of your configuration, execution, what and how the crawler interacted with each project is kept. So for each of these logs, you can search through. So for this one, for example, I got 20 projects scanned, 3 were okay, 17 had errors. You can then double click on these to get to the actual log file. and then use these auto error searches to sort of jump through, look at each error, try and understand why the crawler wasn't able to open or read these projects on this crawl. The Tags Manager is another location for you to manage the tags or user strings or metadata that you want to store against each project. So you can click on a particular tab, see all the projects that have that tag assigned, and then there's tools for merging, deleting, etc. The Seismic File Manager is a new tool for Tracker 4. This allows you to search on a particular path for SegY, SGY, or ZGY files that are just stored under this path. You can also check those files to see if they're stored against the database, and it will also make a suggestion for reconnection of these files on disk based on missing links in Petrel projects. This is executed externally or separately from the main sort of crawler execution. Project Manager. This gives you control over project actions on a project-by-project basis now. So executing a rescan, you just need to toggle to choose a subset of projects as rescan candidates, as opposed to previously this was all executed as a bulk. It was executed as a bulk rescan. It's also possible to exclude projects from duplicated seismic analysis, exclude from the rules, lock it into the database, or set it as a reference project if it doesn't have a Petrel extension. So the final update to the Tracker 4.0 Tracker Admin is the introduction of the project upgrade dialog. So it's now possible to run a bulk upgrade on Petrel projects to the currently used version of Petrel. It's just a case of toggling which projects you would like to upgrade. You can click validate to check preconditions like write access, etc. And then you just click upgrade, and it just makes a basic open save in the new version. So this utility is part of what's called Tracker Utilities. It's licensed separately. The license currently costs $0 and is available on the Ocean Store. So if you have recently upgraded to Tracker 4, please get in contact with us and we can unlock this utility for you. So that completes the run through of the admin GUI, Tracker Admin, sorry. So there's lots of new features gone in, as you can see. So just to recap, we've worked through the configuration. We've selected what data we want to scan for, which folders we want to crawl in, the measurements, the analysis, database connection, etc. So we're happy with the configuration. The next thing is to execute the crawl. So the crawler is going to go off, find all the Petrel projects, interrogate them, aggregate all of the pertinent information in the Project Tracker SQL database. Once you've reached a stable database, populated with as much data from as many projects as possible, it would be then recommended, as I mentioned, to set this crawler execution up as a scheduled task using Microsoft Task Scheduler. This will allow you to execute daily or weekly scans, for example, and record and monitor the changes to the Petrel network with a regular set of measurements. So now we've run the crawls, populated our database. The next component to look at is the Tracker web. So this is the web-based front-end view of the database. So when you initially open the Tracker web, it opens to the dashboard view. So the dashboard gives a brief overview of the Petrel projects in the database, the version summary, information, crawler execution details. So you can see the window split into 4 sectors. So top left we have summary tables for local data. So for each project, the number of local data that are in there that have come in without using reference project tool, the 100 newest projects on the network, the 100 last modified. So for all of these tables and projects and data in this Tracker web front end, you can click on any given project, for example, open information in the project inspector. So I can see the version, when it was last modified, who the pet file owner is, where it sits on disk, the reference status of the data, the units, the disk composition, the history of the project, and the coordinate system if it has one. Similarly, I can click on a particular user, get to a list of all projects associated with that user. Underneath we have the crawler timeline. So this is a kind of visual representation of when you executed crawls. So for each day or week, you get a little timeline bar. You can sort of hover and highlight and get information on the number of projects scanned successfully, when it was executed, etc. You also get a number of days since the last execution. It's also possible to access all of your log files from the web front end. So I can click to open a log file in a quick browser and scan through as necessary. Top right, we have the key measurements. So this is a graphical representation currently displaying the number of 2012 projects, 2011 and 2010, for example. This can be customized to show any of the metrics that you're storing in the database. Project tags allows you another opportunity to utilize the metadata that you've assigned. So I've assigned an NNS tag to a list of projects. So this could be by asset, by country, etc. Bottom right, we have the Petrel version diagram. So this is a graphical representation of a breakdown of your Petrel network by version. So 2005, for example, I can click, get to a list of all those 2005 projects. Again, open the project inspector, see who the pet file owner was, when it was who it was last modified by. You know, it's a 2005 project. You can contact the user. Can we, archive it or upgrade it, please? So that was a quick run through of the Tracker web dashboard. So there's a number of different tabs to work through here. So the next one down is the Projects tab. So this is a list of all projects in the database. So we can see columns for project name, the path, the computer name, Petrel version, is it a reference project, tags or metadata that you've assigned. So there's quite a lot of functionality within these views to show you. Firstly, on filters. So I can search project name starts with ref, for example. Just a quick example of searching on a string in a project name. If you use lots of these filters, you can save them and quickly recall them, or load and manage them through the filter sort of manager. So I have a series of filters that I work every time I come and look at the database. So you can save them and quickly recall them. So also within these tables, it's possible to make a selection of a project row, and then you can add tags or remove tags as necessary. You can open the project in Petrel directly from the web front end. You can also open the disk location of this particular project if you would like to take an action against it, i.e. remove it. And if you do remove it through Windows Explorer, you can then click to delete the project from the database, so your network and your database are still in sync. So a couple more functionalities to show you with all these tables is to group by, for example. So I can group by a column header, so Petrel version. So group my projects by version. I get a list of all my 2008 projects or my 2007 projects, for example. It's also possible to make a selection of projects. Right-click, export those rows to Excel, export to CSV, or to the clipboard as necessary. So there's a number of quick views to work through here under the Projects tab. So we've looked at the overview. Next we have the history of the projects. So the history view displays the history of all the Petrel projects, when it was created, last modified by, project owner, etc. So you have all the same filters and functionalities we just looked at. So for example, I'm going to recall a pre-existing filter for projects not modified within 6 months. So last modified is less than 1st of September. So here I have a list of all projects that have not been modified within 6 months. So the next view down is the sizes view. So sizes list the sizes of the project file size, the size of the ZGY, raw, project folder, and the simulation folder. So it's possible to sort all of the tables ascending or descending. Then I can come into any particular project here, open up the Seismic files, get detailed information on all the Seismic objects within a particular project, so how it's stored, the bulk value type, does the file exist or has it been dropped. And again, you can sort these ascending, descending to get more structured information on the seismic of each project. So the next view is the units view. This reports the project units defined for each project. Then we have a scan status. This shows you the status of each project with respect to the crawling process. We now represent any associated scan errors as well in the database. So if there is a scan status error, you can get the information from the relevant log file is displayed in this view. Next view is the CRS. So this is the table showing all projects in the database and their associated coordinate system. Again, we can use this group by functionality. So group by coordinate system to get a unique list of coordinate systems on our network. And then here we have all the null projects. So quickly generate a list of all projects with no coordinate system, for example. The final view to look at is the references. So I'm just going to show you the seismic ones. So this gives an overview of data origin, whether it be the object has its origin in a reference project or a local project. So here I can see for this particular project I have 36 2D lines that are newer than the same objects in a reference project. Here I have 122 lines that are not referenced. So I can drill down further, click on those that 122, get to a list of those 122 2D lines in that project that are not referenced. For example, click on a particular GUID and then see all unique occurrences of that particular object. Come into the data network graph and see how those three occurrences of the same data object have kind of evolved and been passed from project to project. So you can see it's possible to investigate with quite some detail the history and evolution of data, projects and objects, be they referenced or not. So moving on to the next tab, is the project data overview. So this lists all objects from all projects. So as you can imagine, it's quite an extensive list. There's various sort of paging options here to help you with display or an export. So this is also where the hash code is presented. So I have a predefined filter here just to record. So this is just going to illustrate that I have it's a porosity log that occurs in twice in one project and then two others, so 3 projects in total. It's 4 different alternative names, 4 different GUIDs, but shares one common hash code. So this is just to show you that we can identify data duplication without using GUID. So also within the project data view we have open spirit data. I'll come to this in a second, and also an original CRS. So this shows all data items with their original CRS where applicable. So moving on to the next tab is the project tree. So this is a new window for Tracker 4, which allows you to use a Windows style explorer to kind of drill down to a particular folder or nested set of folders and generate summary statistics. So you can drill down by asset or by if users have user projects and kind of get summary statistics, so a graph of Petrel version, numbers, disk utilization, projects without a CRS, so there's 51 projects in this particular folder that don't have a CRS. There's 30 projects that have been modified in the last 30 days, and there's also 13 projects which have not been modified in over 5 years. So quite a nicely presented way to get summary statistics by folder. So the next tab is the project rules and alerts. This is a summary by project of which rules have been broken by that particular project. So earlier we talked through configuring the rules in the project manager as part of the Tracker admin GUI. So as each project gets checked against the rules that we saw earlier, there's the facility to automatically email data managers and users. All of these failures are also recorded in the database and can be viewed here. So for this particular project, AR1514-2, the project contains duplicated seismic. It has some seismic stored within the project folder and also has been stored in a non-recommended location. So the next tab is the Open Spirit Projects tab, which provides a list of all different Open Spirit projects utilized by Petrel projects on the Tracker network. This requires the data exchange license to be available at the time of scanning. So for each OpenSpirit project, we can click on the project folder to see all Petrel projects that have data in from that particular OpenSpirit source. Or we can click on the data folder to see all data objects from that particular OpenSpirit source. So we have the OpenSpirit data name, data source, last modified, and OpenSpirit key represented. The measurements page allows you to graph the measurements and metrics that you've recorded with each crawl. So again, the idea is once you've populated your initial database, to run regular crawls on a scheduled task, record regular metrics and measurements, and be able to build a picture of your Petrel network with time. So this is a representation of Petrel version by all of these different metrics. Another one to show you is disk utilization, for example. So again, you can sort of monitor how Petrel's utilizing disk space. If somebody starts to realize lots of seismic or run lots of simulations, you can see that in terms of this graphic and take an action as necessary. So the next tab is the Seismic Bulk Files tab. This allows you to show, this view shows you all of the seismic bulk files on the track network. You can get an overview of the bulk files per project, how they're stored, the sizes, the disk path, etc. So one useful thing to show here is, for example, if you're searching around on disk and you happen to come across, are there the segwire files sat on disk in this particular location? So the question is, are these used in a Petrel project? So you can make a filter in the seismic bulk files to this using this location string. So I have a predefining filter I can recall. So path starts with location of the seismic we found. So then I can see that, okay, yeah, in this example, one of those segwire files is utilized by 10 different projects. So the duplicated seismic shows you information on where all duplicate seismic objects have been found. So if I sort descending, so here I can see the same 1.4 gig cube occurring in 2 different projects, and the same 370 meg cube occurring in 7 different projects. So this table and data will allow you to plan and monitor a seismic data cleanup, allow you to reference data correctly, rationalize the seismic down, and ultimately reclaim valuable disk space. Next tab is the network graph. So the 2 tabs, copied projects and reference projects. Copied projects graph shows a chain of projects where projects have started out as a copy from another project. If a project's not a copy of another project, it won't be shown. So you can hover to get relevant information on each of the projects. You have all the standard tracker filters available as well. The reference project network provides a network graph based on a particular reference project. So for this particular reference project, I can click on the network icon and get to view a sort of graphical representation of all projects that have data referenced from this particular reference project. Again, I can sort of drill down into this, get to a list of all those reference data objects from this particular reference project. Okay, so that was a quick run through of Tracker Web, so the front end view of the Tracker database. Next, I'd like to show you the integration of the database with Excel and Arcgis. So starting with Excel, I'll quickly show you how to bring data in from SQL Server and start to work in analysis outside of the hard-coded web front end that we've been looking at here. So it's possible to come to data, connection from SQL Server, just paste in our server, choose the particular Tracker database, then we have a predefined view built to this project ref data tags. So this is quickly just brought in from the SQL database, so the project name, the path, the version, information on the CRS, the disk composition, and all the reference data, etc. So you can start to use the sort of native functionality within Excel to work additional analysis. So for example, we can bring in a pivot table, toggle project ID and Petrel version. change this to account. So we quickly have a count of Petrel projects by version. We can represent that with a pie chart, for example, or we can swap to coordinate system. So account and graphic by split down by coordinate system. Or we can also, if we drop this and have version and as modified by. So we can get a table of account of different project versions by user, for example. So just a quick couple of examples to show you that you're not necessarily constrained to using the web. Then you can integrate with Excel. So the next thing to show you is the integration with Arcgis. So I mentioned a couple of times when you have the spatial extension license in place, we can record spatial information about projects and objects in the SQL database. So if we have a look down the legend here, we can see the different, an example of some of the different data types we record. So here we can see we have all of our 3D cubes represented, or 2D lines, or well locations. Where we have associated interpretation can be represented for a particular cube. We can also see all non-reference data, so non-reference 3D cubes, 2D lines and wells in their geographical positions. And then at the bottom here we can see these mispositioned data. So this is so basically when the crawler finds objects that match on GUID or name, the spatial location of those duplicate objects or named objects is checked. If certain criteria are not met, both objects are flagged as mispositioned. So basically we can find and highlight to you duplicate Petrel objects in different geographical locations. So we can see all of these different data types from different projects displayed together, which allow the data manager to build a broad, live geographical overview of the Petrel network. So the way this works is to utilize the native link from SQL Server to Arcgis. When we record spatial data to the database, it's stored as a geography data type. This geography data is recognized by Arcgis 10 onwards and can be loaded as a query layer. So a query layer, you come to File, Add Data, Add Query Layer. We just make a connection to the database. So these are a set of predefined views in the database which contain geographical information. So we can come to our spatial seismic cube, which is our 3D cubes. Click to finish. It's going to make a query against the database, then quickly draw a polygon representing the spatial location of all of our 3D cubes. As we're querying against the database, we can also bring in attributes against each object displayed. So here for Petrel project, I can come to Open Attribute Table. So I have available in Arcgis the project name, the path, the version, who it was last modified, etc. So you can start to label these data as they're displayed by these particular attributes. So in this case, you can see I've broken out my Petrel project by version and have a different coloured polygon on the display representing these different versions. So also important to note that what we're seeing is a live reflection of the scanned network. So once the database connection is in place and the Arc project is refreshed, any new data loaded into a Petrel project and that has been subsequently scanned will automatically display the next time you open Arc. So as you can see, this is an excellent tool for the data manager to build and maintain a broad geographical overview of the Petrel network. So moving into the final part of the demo, and the last piece of the integration of the tracker database is within our Blueback toolbox. So at the start of the webinar, I introduced the Blueback Reservoir Data Management Suite, and we're going to look quickly at the Project Management Toolbox part of the Data Management Suite. So as I mentioned, the toolboxes are a set of functionality features not available in standard Petrel, designed to maximize your Petrel investment. And there are toolboxes designed for the geophysicist, so various sort of seismic analysis tools, toolbox for the geologist or reservoir modeler, a reservoir engineering toolbox, which contains water saturation modeling, new Tata gridding process, pressure gradient analysis, and then what I'm getting towards here is the project management toolbox. So this is a set of tools for both the user and the data manager to manage the contents of their Petrel projects. We also provide additional support for import-export formats. There's a project scanner to allow you to quickly scan the XML files and PTD folders. A project report if you wish to document the contents of a project before archiving perhaps, or you want to understand a newly inherited project. Then these three tools are what I'm working towards here. So the Tracker Data Browser, Tracker Duplicated Seismic, and Tracker OpenSpirit. So the Tracker Data Browser basically allows a user to connect to a pre-existing Tracker database. So they just plug in the server name, give them the authentication, or they can use an existing config file. So the user would then check the date to see what they're comparing against, and then they can basically sort of filter on a porosity log, and so they can check check other occurrences of all the same data objects in their user project in other user projects. So here, for example, for this particular porosity log A15, I can see that the data I have in my project is newer than the other 6 occurrences of this same object in these other user projects. So it just allows the user to check whether the data objects they have in their project are newer or older than all other occurrences of the same object in all other user projects. Tracker Duplicated Seismic, again a tool for the user to see where there's duplication of seismic. So again, you would just connect to the database. You get a list of all the objects in your particular project, and then the number of duplications in other user projects. So here I can see, for example, there's 5 other occurrences of this particular seismic object in these particular projects. You can actually open this up, see where the project is, where the file is on disk, and then take an action, go and open the data in Petrel and check the duplication. So the final tool in the project management toolbox is the OpenSpirit, Tracker OpenSpirit. So again, with an active connection, the user can see a list of all objects they have in their project that have been transferred via OpenSpirit. So the table shows the user the OpenSpirit source, project type, when the object was last modified against the OpenSpirit session, and the OpenSpirit key. So that concludes the demo. For now, I hope you find it interesting. I'm just going to jump back into PowerPoint for a couple of slides to summarize and to wrap up. So we've seen that the Project Tracker provides a powerful toolkit for understanding and tracking all of the Petrel projects on your network. Regular scans allow you to implement metric-driven data management policies and procedures. The business rules allow you to automatically check each new or existing project against a standard set of criteria with automatic notification and reporting. The database is open and customizable, allowing you to build your own measurements, rules, views, and you can also record spatial elements of each project, then integrate these data with Arcgis to control the QC and spatial integrity of the data users are working with. So all of this combined shows you how the Blueback Project Tracker is designed to be the tool for the Petrel Data Manager. So just a quick slide before I move on to the licensing and evaluations and stuff. Just to let you know about the Tracker User Group meeting, which is taking place it's the second one now, taking place in Copenhagen on the 28th and 29th of May. So if you would like to come and share your experiences of Tracker or learn from other people's experiences or find out more about Tracker, then please get in contact with us on sales@blueback-reservoir.com. So the Project Tracker licensing and all the modules we've discussed, so spatial, geodata exchange and utilities, are all available on the Ocean store, www.ocean.slb.com, along with all the other Blueback plugins. Tracker has different license levels based on the number of projects you require to scan, and the spatial, extension, data exchange and utility modules are all available as separate licenses, as I mentioned. So there's various different options we can offer you in terms of if you want to deploy to multiple sites, different deployment options, centralized databases, localized databases, etc. So please get in contact with us on sales@blueback-reservoir.com for further information. So all of the Project Tracker modules and functionalities can be tested for free and no obligation to purchase evaluation. We can organize the licenses on your behalf, assist with all aspects of the installation, configuration and scanning, and initial database analysis. Again, it's sales@blueback-reservoir.com if you would like to find out some more information. So the last thing before we move on to the Q&A is to introduce a new product called Tracker Services to you. So consultants are now available to provide tracker services, and these are available on different levels of complexity depending on what kind of assistance is required. So, for example, we have software as a service where we can come in, scan a network for you a couple of times a year and provide a basic report. Inventory and validation, so this is using a working installation of Tracker on site. We can acquire a project and data inventory, validate the key reference data, which will include a spatial analysis, and this service will also deliver a comprehensive report and plan for cleanup. Cleanup and QC builds on the inventory and validation where we can undertake the cleanup of Petrel projects, reduce seismic duplication, QC the data of the projects and the networks. And of course, we can provide more in-depth help and support and training as required. So again, if you would like to find out more or discuss your requirements with us, it's sales@blueback-reservoir.com. Okay, let's break out some questions, see what's come in. Okay, so we currently provide support for Petrel 2011 and 2012. And the SQL Server database that's required is 2008 or 2012. This is the SQL Server version that has the geography data type or supports the geography data type, which will allow you to utilize the spatial extension module. The tracker is very flexible install-wise, so the components can be broken up. So the web front end, the crawler, and the SQL Server database can be pushed into a virtual environment. They can be split on different office sites, or they can be all on a single machine. So we see quite a varied ways of implementations by different clients. So if you would like to know more about the installation requirements and how it can be configured or deployed, again, it's sales@blueback-reservoir.com. Okay, so that's it. Thank you all for your participation. If you have any more questions, you know the email. Again, another shout for the Tracker user meeting in Copenhagen on the 28th and 29th of May. If there's any other questions that have come in that I've not answered, we will get back to you via the email. And lastly, you'll all get the recording of the webinar tomorrow, so please feel free to distribute as you require. Okay, thanks again for your participation, and goodbye.